It's a pleasure to have the opportunity to interview you, Dr. Dow, in the laboratory of the R.S. Dow Neurological Sciences Institute, the institute which is named after you and which you founded more than 30 years ago. You've been in Oregon for almost how many years? 85 years? Close?
No. I came here when I was 8 years old.
When you were 8 years old.
Born in 1908.
And moved to Oregon, McMinnville.
McMinnville
when you were 8.
When I was 8.
And from McMinnville, you went to public school?
Yes, in McMinnville.
And your father, if I recall, was a teacher?
No, he originally was a teacher in Ray, Colorado, where I was born, the first principal of the high school. And he married one of his pupils, who was my mother, of course, and they were born January 1st, 1900 in Ray.
And what did your father do when you moved to McMinnville?
He bought and edited a country newspaper in Newberg, Oregon, which burned shortly after his purchase, and then he went into the furniture business in McMinnville. And as I was growing up, he was the proprietor of a retail furniture store.
And did you have brothers and sisters?
I had an older sister, 6 years older, and after my parents moved to Oregon, they had 2 younger brothers, one 10 years younger and the other 14 years younger. So my contacts with my brothers and sisters were a little bit different because there was such an age difference.
And after going through public schools in McMinnville, I know you went to Linfield College.
Right.
And
that was one of the reasons that my family moved to McMinnville, because they wanted to assure that all of their children had an opportunity for a college education.
And what are your recollections of Linfield College? What kind of a place was it then?
Well, it was a Baptist school with about 300 students. They were in a building program, and the name was changed shortly before I enrolled to Linfield College out of because of a benefactor to the college. And so it was in a period of expansion, and I had already decided that I would enter a course of pre-medics at that time. Majored in chemistry, minored in biology.
But I recall in our conversations that you very much appreciated the guidance of Professor McNabb.
Right.
I wonder, what kind of a person was he?
He was a very unusual professor for a small college of that time, and that he had tremendous interest in research. And he was a very meticulous teacher. He had a variety of research subjects, ecological, biological, marine biology. He was interested in a variety of things, but always from a research point of view. And he encouraged his students to get involved in research, and many of them went on to graduate school from that small college. In fact, it was determined that during his tenure as professor of biology, there was a larger percentage of graduate students from this small college in relation to the total enrollment of any school in the country. Professor McNabb invited me to be a laboratory assistant, and I stayed for 4 years at Linfield rather than going on to medical school after 3 years, which was possible at that time.
So you spent a total of 4 years
at Linfield.
McNabb must have seen something in you in order to have made the invitation. I wonder what it is, if you could characterize in words, that interested you about research at that level. What experience that did you have that excited you?
Well, his example, I think, more than anything else. And then he encouraged me. He said, don't be just a regular doctor. You specialize. Make some contribution. And that was an inspiration to me.
How would you recognize, if you were in the same position as McNabb, how would you know which students to give that advice to?
Well,
or would you generalize the advice to all students?
Well, I would take someone who exhibited some originality in their work, who was exact enough in their observations that he could depend upon their observations. And as I said, he was a most exacting person. If you made a drawing through a microscope, it had to be just right to suit McNabb.
So from after completing your year as his research assistant, then where did you go to medical school?
Well, then I, of course, decided to go to the University of Oregon Medical School. And on the admissions committee, when my father and I came up to interview Professor Larsell, who was on the admissions committee and had been a graduate of Linfield as well, we explained to him my financial situations and the difficulties that I would have in getting through medical school. And he understandably said that, in view of my experience with McNabb, if I succeeded in getting top grades, I could apply for an assistantship in anatomy and take a master's degree along with my MD. And of course, that offered an opportunity to do a little more in science than just the regular medical courses. It did require that I spend 5 years in medical school to accomplish that. So while I started medical school in 1929, I actually graduated in 1934. And as I proceeded and fulfilled the master's degree program, Larsell encouraged me to stay a 6th year and obtain a PhD degree in anatomy, and I did so.
Larsell is affiliated. Larsell's name is mentioned prominently in any historical record of research on the cerebellum. Is it accurate to say that he was, and so is your name, and I'm wondering if it's accurate to say that he was one of the earlier influences in your career in focusing you on problems anatomical and physiological related to the cerebellum?
Yes, particularly in comparative anatomy, and this was Larsell's forte. We did published a paper on the innervation of the lung first, and that's an interesting story, but aside. And then he wanted me to study the development of the cerebellum in an animal that had a large vestibular component. And we chose, or he chose, and I carried out his directions and wrote my master's thesis on the development of the cerebellum in the bat. This fulfilled his belief that one of the fundamental divisions of the cerebellum was the floccular nodular lobe, which is the principal recipient of vestibular input, and the corpus cerebelli, which in reptiles is about of equal size, but in birds and mammals, the corpus cerebelli completely overshadows the floccular nodular lobe. But we found that the first fissure to develop was between these two divisions in the embryo bat.
I wondered if, would it surprise you to know that many people still refer to Larsell's definition of what these lobules are in the floccular nodular lobe, and in fact, in one of his earlier papers, Larsell defined an area of the floccular nodular lobe, which he later corrected in a subsequent publication. and might have even appeared in the 2-volume series that was edited by you and Dr. Jan Janssen. And because people read the first paper and didn't read the revision, many of the experiments done in primate physiology, which have claimed to have recorded from the flocculus of the monkey, have actually recorded, according to Larcel's later paper, from the paraflocculus, and has thrown that field into somewhat of a complication.
Well, there was a confusion between the flocculus and the paraflocculus at that time, and my next work for my PhD was to define the areas of the cerebellum that received vestibular input. And although Brodal and some others with more refined techniques had found some projection more widespread, using the Markey technique, we found that these vestibular fibers went to the flocculus, the nodulus, the uvula, and the lingula, and directly to the fastidial nucleus. And this was a work done in the cat and the rat at the medical school while I was there for those 6 years.
After completing your studies in, at the University of Oregon, I know you went on quite a series of postdoctoral fellowships interacting with some of the seminal figures in both neuroanatomy and neurophysiology. What was your first stop after, after graduating?
I interned at the state of Wisconsin General Hospital. They had a program of exchange of interns between Oregon and the University of Wisconsin. And I was still anticipating going into clinical medicine. So the next step was an internship, a rotating internship at Madison. And there I met a professor of neurology, Dr. Hans Rees. And he acquainted me with the possibility of furthering my career and my education by taking a series of postdoctoral fellowships. And I applied for a National Council Research Fellowship and selected the laboratory of John Fulton at Yale as the place where I wanted to spend my first year of fellowship. And Dr. Rees was helpful in that, as was C. Judson Herrick, who had been one of Larcel's teachers when he was a student. And I recall very well that both of them helped me obtain that fellowship with Fulton.
How did you encounter Herrick? Because I was an undergraduate at the University of Michigan, where he founded, I think, the Department of Comparative Neuroanatomy. How were you, coming out of Wisconsin, familiar with Herrick's work?
Well, Larcel gave me a letter of introduction to him in Chicago, and Mrs. Dow and I spent an evening with Herrick, and he was familiar with my work with Larcel.
So then your first stop was with Fulton, who was considered one of the seminal figures of American physiology. And in what problem did you work on when you were at Fulton's laboratory?
Fulton had a laboratory of primate animals, which was unique, much before primate centers were even thought of. And of course, I was in a laboratory with a tremendous number of other postdoctoral fellows from literally all over the world. And Fulton had the capacity of putting us in a laboratory, of giving us every facility and encouragement, but giving us very little direction, and would give us complete freedom to do what we wanted.
Sounds familiar.
And so I thought, after determining that the vestibular part of the cerebellum was largely in the nodulus and flocculus, and the nodulus was the most accessible part of that portion of the cerebellum. I, in the very sophisticated surgical facilities at Yale, began to experiment on monkeys and ablated the nodulus and the uvula, and observed the results of that ablation in the cage behavior and reflexes and other observations we could make on primates, and observed that it was a transient disequilibrium syndrome which lasted for several weeks in the monkey and less long in the baboon and the chimpanzee. Then, in order to further identify that it was the vestibular input that the cerebellar ablation was affecting, we did a series of experiments of labyrinthectomies in monkeys, a baboon, and a chimpanzee, and observed as phylogenetic development occurred, this influence of a labyrinthectomy was less marked as we approached man. And it was well known that there was a considerable difference between monkeys and man, and this was a progressive thing that followed phylogenetic development. Once the animal had stabilized in its disequilibrium after bilateral labyrinthectomy, I then went in and removed this part of the cerebellum, and nothing was added to the syndrome. And that proved to me that this, in fact, was a vestibular effect. While I was at Yale, Fulton urged me to apply for a second-year fellowship, and was arranged an interview with the Rockefeller Foundation to finance this fellowship, and I particularly wanted to go to Europe. The representative from Rockefeller came down, and he interviewed me, and it was obvious now as I look back that I was still undecided as to whether I wanted to be a clinician or a basic scientist, and he sensed that, and I did not succeed in getting the Rockefeller Fellowship that I had hoped for. Fortunately, however, there was a neurosurgeon in Fulton's laboratory from Brussels, Leon Ectors, who had come there under an exchange program between Belgium and the United States, which had been founded by Herbert Hoover after World War I. And he encouraged me to apply for one of those fellowships as an exchange to Belgium from the United States, and to spend a year in Frederick Bremer's laboratory. And this was a most important and circumstance, fortunate that year with Bremer. Bremer had spent a year with Sherrington, a year in Boston as an exchange fellow under the same program in his day. And during that year in Bremer's laboratory, for the first time I was introduced to electrical methods of studying the cerebellum. Previously it had been just anatomy and ablation experiments.
So failing to get your first fellowship because you're indecisive about whether to be a scientist or a clinician, you seem to have taken a long time to make up your mind.
That's right. I can't deny that.
When are you going to make up your mind?
Well, I've had the good fortune to have been engaged in both. And I think there are advantages that accrue from being interested in science and being able to attract people like yourself to do science under some encouragement, much like Fulton. I took the same position with the people at we recruited into the Institute that I had helped them get started, give them every facility that I could manage to acquire, and they do what they wanted. And I remember very well that I expected you to work on the cerebellum, but it took you 10 or 20 years to do that.
About 10.
But during that time, you did some very productive work, and I was content. The next year, I wanted a third year of fellowship and arranged to have that at the Rockefeller Institute in New York under Herbert Gasser. Although he was not active in the laboratory at that time, Harry Grunfest, Lorenda Deneau, and Adrian Renshaw and myself were the people of younger age who were working actively at the Rockefeller.
And I was wondering, before you came to Rockefeller from Belgium, Gasser is attributed the discovery or the first physiological use of the oscilloscope in the United States. But you, in Bremer's laboratory, what kind of equipment did you
We had oscilloscope. Wasn't a cathode ray tube. It was a much more primitive type of, but we could measure the electrical activity of the brain and of the cerebellum, and confirmed Adrian's observation that the cerebellum has a rhythm which is about 10 times or 15 times that of the alpha rhythm of the cerebral cortex. And Bremer, first I tried to see if we could record an event by electrical stimulation of peripheral nerves in the spontaneous or ongoing activity of the cerebellum, and was unsuccessful. But he had observed when he was in England that if he stimulated the cerebellum and observed the rebound effect after the cessation of stimulation, which is characteristic of cerebellar stimulation, that there were some peculiarities of this rebound effect, and he suggested that I try different strengths and duration of stimulation and see what that did and what happened when you had a cessation of stimulation. And that I did. And we found that if we stimulated the cerebellum for a long enough time and strong enough, then there followed an after discharge of great augmentation of potential of this peculiar fast rhythm. And there was a definite correlation between the rhythm, its amplitude and duration and cessation, with the effect of the anterior lobe of the cerebellum on decerebrate rigidity. And Sheridan had found earlier that that was probably the first electrical stimulation of the cerebellum to have a physiological effect. Before that, because it didn't cause movement as the cerebral cortex in experimental animals, they assumed that it was inexcitable, but it wasn't. And you could then correlate the activity with a physiological event. We also did some other observations on local application of cocaine and strychnine and things of that kind, and that resulted in a paper on the electrical activity of the cerebellum. During that tenure, I was most fortunate to have as another postdoctoral fellow in the same laboratory Giuseppe Maruzzi.
Oh, so that's how you met Maruzzi.
That's how he met. He had a Rockefeller Fellowship and was studying at Bremer's laboratory. And Bremer, when he was in Boston, had become very well acquainted with Percival Bailey, who was the pathologist in Cushing's laboratory, and Percy had a sabbatical months, about 6 months, and he used that sabbatical to come to Brumare's laboratory. They were good friends from their Boston days, so Maruzzi, Willetta, my wife, and Percy made the tours of Europe, and Bailey had a lot of experience in Europe, and of course Maruzzi, and so this was a wonderful experience.
Well, after World War II, Italian physiology very much flourished, largely under the leadership of Maruzzi, and I know that you and he later collaborated on a book on the cerebellum. In fact, I have it here entitled The Physiology and Pathology of the Cerebellum. When exactly did you work together on the book? Was this was during the sabbatical, was it?
No,
in the
no,
50s?
this was in the 50s. Our first experience together was in the 30s.
Yeah.
Larsell had been working on the comparative anatomy of the cerebellum throughout his life. He hoped to have his life's work published, and asked me to write a chapter on some clinical aspects so that there would be a better sale for the book, and I wasn't too interested in that. But in the meantime, he left Oregon and took the professorship of neuroanatomy at the University of Minnesota. And he arranged there to have a publisher publish his work. And I thought of the possibility that instead of having an anatomical book, we could have 2 volumes, one on anatomy and one on physiology and pathology. And I said, if you can get your book published, perhaps they would publish one that Maruzzi and I could write together, and he dealing with primarily the physiology of the cerebellum, and me the clinical syndromes and the pathology. And this was arranged, and I applied for a Fulbright fellowship to go to Italy for 6 months. Well, it was longer than that because I traveled in Europe in the 50s and arrived in Pisa, where Maruzzi was located in the fall of 1953.
So was he a difficult man to convince to collaborate on this book?
No, he was interested in doing it. It wasn't. It was a suggestion, but we had enjoyed working together. We published several papers together while we were at Brumare, and this appealed to him because he had a great interest in the cerebellum throughout his career.
Returning to the progression of your education from your stay in the Rockefeller, then did you return to Oregon?
Yes, I had attempted to alter the electrical activity of the cerebellum from the periphery and by stimulating the cortex and other parts of the central nervous system. So Harry Grunfest suggested, well, if you want to do something like that, just give a single shock. Don't try to stimulate it continuously, and I took his suggestion. And that work at the Rockefeller involved stimulating all the different afferent inputs to the cerebellum and recording from which lobes the action potential was observed. And this led to my thinking that the afferent input would give us some clue as to the function of different parts of the cerebellum. Ingvar, a comparative anatomist in Sweden, had proposed the idea that the vermis was not a single unit. There were parts of the vermis that had different functions, and I had already found that the vestibular part of the vermis had a different function than other parts of the vermis. So this was the natural progression of my electrical studies of the cerebellum.
So when you returned to Oregon, was it to accept a faculty position?
Yeah, assistant professor in the Department of Anatomy.
Did you intend at that time to continue your to develop a clinical practice?
Not originally, no. This was in the Depression years, and I was content with a salary of $3,000 a year. I remember very well. And we came back to Portland.
Does that include the parking?
I don't know about that. we came back to Portland, and I brought some pathological material from my 8 months in Belgium on multiple sclerosis. And Mrs. Dow had studied histological technique right after our marriage. She helped me very much during my PhD thesis, all the histological work. She processed these pathological multiple sclerosis slides. And during that period, that was during World War II, I found out that I was eligible to take my boards in neurology, even though I had had no formal training in clinical neurology. Approved residency programs were not sufficient. And if you had an internship and had 3 years of practically anything in the nervous system, you could take your boards. And during my tenure in Belgium, I came under the influence of von Bogart, a very famous Belgian neurologist, and a neuropathologist by the name of Scherer. So Mrs. Dow and I traveled to Antwerp 2 days out of each week, and I was tutored in neuropathology by Scherer, and she learned some very special histological techniques in neuroanatomy. And and also during that year in Belgium, which I wouldn't have been able to do if I'd have gotten a Rockefeller Fellowship, I could take 4 months of that time to travel outside of Belgium. And I took 3 months and had a clerkship at the National Hospital, Queen Square, under Dr. Gordon Holmes, who has done the most, still to this day, the most important work on the clinical symptomatology of cerebellar injury. And that was a very valuable and practically my only formal clinical training at the National Hospital, Queen Square in London.
So you spent several years as in the Department of Anatomy, but in the meantime you've got your board's certification
Yes.
in neurology.
In neurology. And during the war, World War II, there was a shortage of physicians. And I became associated with Dr. John Roth, who was the only neurosurgeon in the state. And I was the only board-certified neurologist in the state. And the medical school was very liberal, and because of this doctor shortage and letting me work evenings and when I could, as long as I did my job in anatomy. And so, I learned a lot from John. He had trained in Rochester and Mayo Clinic and was a good neurologist as well as a neurosurgeon. And we worked together for about 25 years, beginning when I first came back on a very part-time basis. And then after 6 years of teaching anatomy, I finally made the decision to go into practice.
When I know that you met Adrian Renshaw in the Rockefeller laboratories, and I know that you tried to have him join you here in Portland as part of faculty at the medical school.
Yes, he did do that. He came. He fortunately died of poliomyelitis after about 2 years in Portland. And that was probably the most devastating experience of my clinical life, was to see my friend die of a bulbar polio within 2 days after coming down with the disease, and I was helpless.
And he's credited with the discovery of what's now called Renshaw inhibition of spinal motor neurons. How young a man was he when he died?
Oh, he was in his mid-30s. He came with 2 children and his wife. and his wife came down with polio. One of the children came down with polio, and he died of a fulminating form of the disease. It was hopeless. After he died, I got a letter from Maruzzi, written, and on the top of the letter, "Destroy this." And he had gone to England to work with Adrian, and was a little hesitant to come back to Italy because his uncle had gotten in prison. And I said, well, I'd like to see you come to Oregon. And he elected not to, went back to Italy, and as you've stated, had a tremendous reputation as a physiologist in Italy.
Think of all the names of the relatively seminal figures in neuroanatomy and physiology with whom you've either studied or collaborated. I'm just going back over the list in my mind. You have Gordon Holmes, Giuseppe Maruzzi, Gasser, Bremer, Fulton. Am I leaving out anybody?
Laurenti Deneau.
Laurenti Deneau.
Harry Grunfest.
Harry Grunfest. Of all those people, is there? Can you find a common characteristic, or can you figure out what it was about them that made them such excellent neuroscientists?
Well, I don't think they were all different individuals. I couldn't categorize them as individually. They were all a great inspiration to me. Bremer was a clinician. He had a practice and had the most famous laboratory in the University of Brussels. That made me see that it was possible to do clinical work and important experimental work at the same time. So that was an influence. I had not too much contact with Gasser, but he did encourage me never to get too much involved in the black box of the oscilloscope. He said, don't monkey with that. He says, you'll waste your time repairing them and building them. You let somebody else do that.
So you ignored his advice, and when you got back to Oregon, you called on an old classmate and friend of yours, Howard Vollum, to help you build these black boxes?
No, that's not just quite right. I came back with a circuit diagram from the Rockefeller Institute, went down to the Oregon State, and they built the first cathode ray oscilloscope to be used in physiology in Oregon. And I brought the built equipment up, and we had some minor modifications to do, and we had to have a camera to photograph the tube face. And they said, there's a very bright student at Reed College who will help you get this thing together, and I stayed clear of it. And I contacted Howard Vollum, and he came and helped do this. And he told me at the time that after the war, he and a friend, Jack Murdoch, were going to start building these things. What a pipe dream, I thought.
So you might have been the first purchaser of a Tektronix oscilloscope.
I could have been if they had been in business by that time. Yes.
After the war, then you turned more to the practice of neurology.
Yes, and to electroencephalography. That was in its infancy. And Fulton had come through Portland with the Office of Research and Development, indicating that now that the war was on, everybody should focus their research on something related to the war effort. So John Roth and I applied for a grant to set up an electroencephalographic laboratory at the first aid stations of the Kaiser shipyards. And they were having head injuries, can't believe. And so we tried to see if we could identify electroencephalographic abnormalities very quickly after a head injury. And we published a couple of papers about that. And then another medical student who I talked into staying and taking a PhD was Archie Tenturi, who later was on the faculty of the medical school. And he did the same kind of thing with some control of the severity of the head injury in dogs. But we found that the electroencephalogram in either the dog or the human was not a delicate instrument to identify the more severe head injuries. In fact, in the human, if it was a mild head injury and the patient was quite conscious by the time he got to the first aid station, the EEG would be normal. And Archie had trained animals with conditioned reflexes, and he found that if we gave a blow to the head of the dog, his brain waves was not as delicate as the effect it had on the conditioned reflexes.
Do you think that's just because you were limited to surface recording, or
well,
for other
could
reasons?
be, but that was the only. It was a demonstration that the type of recording we were doing through the skull was certainly not a delicate way of studying brain physiology.
Head injury experiments have become quite controversial over the last few years, as you know. Wondering in your own mind how you balance the complaints of people that are abhorred by the idea of producing head injury in order to study the problems of head injury.
Well, I would never have been able to get approval of those experiments under the present circumstances. I don't think. They were cruel, and I have to recognize that. But animal rights people were not vocal at that time at all. We didn't widely publicize this. We anesthetized the scalp and went ahead with our head injuries.
When did you decide to move your practice and research to Good Samaritan Hospital?
That was after 6 years at the medical school. The dean said, we hired you to be an anatomist, and if you want to stay here, you'll be an anatomist. And that was about the ultimatum that I received. And I had to tell Larcell that I was leaving the department, and I recall very well his consternation, and he said, would you desert science for the flesh pots of clinical medicine? And I reminded him that after all, he had spent his life as a teacher of medical doctors. Did he think so lowly of that profession? But he was distressed about that. And then my associate, Dr. Raff, had established a residency program in neurosurgery, and most of the neurosurgery that these residents were trained were done at Good Samaritan, and our practice was largely at Good Samaritan. And I was responsible for a year's rotation of those neurosurgeons through neurology. It was more of a preceptor type of postgraduate training. And I got the idea, well, if he can train neurosurgeons, perhaps I can train neurologists. And in order to do that, we had to have a research facility at the hospital. And that led to the establishment of the Laboratory of Neurophysiology, and you were one of the early recruits to that laboratory. I had difficulty in getting postdoctoral fellows and other younger scientists to come. So in order to fulfill the obligations of a R01 grant, which I was fortunate enough to get, I contacted Maruzzi. He suggested that I bring Hermano Mani to Portland, I contacted Granit in Sweden, and he suggested a physiologist in German by the name of Hinach. And my contacts in Mexico brought me into touch with Fernandez Guardiola. And those three scientists of reputation and experience were the first really people to come to the laboratory, and it was through their efforts that the first publications occurred.
After those three people who you mentioned came here, then there was Kurt Bell, I guess, was the
he was one of
first
the
of the
early,
people that's still
right.
here.
John Sweat was
John
an early one, and
Charles Barassa.
Charles Barassa. At the conclusion of our book, it seemed to me there were three areas of investigation which needed further investigation, and one was the relation of the cerebellum to the gamma motor system, and that was Hinach's field, and he worked on that. I was already felt that there was a possibility that cerebellum had an influence on convulsive phenomena, but nobody had ever prepared an animal with a chronic epileptic disorder and then stimulated and cooled and ablated the cerebellum and see what that had effect on a ongoing chronic epileptic model. We did it in the rat and were successful in showing a relationship, and one of the early people in the laboratory, Dr. Grimm, who you know quite well, tried to repeat that in the cat and monkey and was quite unsuccessful. But in the rat we felt we had some good evidence that there was an influence which we could demonstrate by stimulation, by cooling, and by ablation.
Then I recall it was 1970 when I arrived here, and Don Rushmer had already preceded me, and both of us were students at the Center for Brain Research at the University of Rochester, and then Lou Nashner arrived also in the same year.
Right.
And then the place grew like Topsy, so now we have 22 people at the Institute. I'm wondering if we look back and tried to, when people ask you how do you start an institute or how do you get it going, what would you tell them? And how are the circumstances similar or different now than they were at those times?
We were fortunate in those early days that it was not as difficult now to get research grants funded. And if you could produce an application for a project, you had a very good chance of getting it funded. I would never have gotten my first grant, studies in cerebellar physiology. Here it was, not in a medical school, in a primitive laboratory on the old part of the hospital, but in those days you could get it funded. And I felt that it was possible to recruit people like yourselves, Don Rushmer, who could come, and I would try to gain enough support to support them for 1-2 years out of funds that I could raise from the Tektronix Foundation and from the Millicent Foundation, which was the precursor of the Murdoch Charitable Trust, and they were generous. And then it was an entrepreneurial setting. We told them, like yourself, that we'll set you up, we'll get you started, you do what you want to do, and then you make your own application, and if you're successful, you have a place. And that's the way it grew. And the person who gave me that idea primarily was Fulton. That's the way he had a host of postdoctoral fellows, and he would just encourage them, open all these wonderful facilities of animals, and let them do what they felt they wanted to do. And I can name people that went through his laboratory during that era that became outstanding clinicians and physiologists.
What do you think that the research has meant to you here at the hospital, and what do you think it's meant to the hospital?
Well, it's meant to me an interest that could not be duplicated by the routine care of patients, much as I enjoyed that. It gave me an opportunity to write, an opportunity to travel, an opportunity to lecture, and that led me all over the world, literally, and I have enjoyed that, and I never have ceased to see that as a part of my career, which was very rewarding. I know friends and trainees that have gotten burned out just practicing medicine. But I always had these other interests and was so glad to see people like yourself come in and be successful, become well known in science. And what small part I had to play in that development has been most gratifying.
What do you see as the role of research in a community hospital such as Good Samaritan?
Well, I think it sets it apart from the rest of community hospitals. It produces an atmosphere that will permit the hospital to recruit staff people of outstanding ability. And I can name a half a dozen who come to be on the staff of Good Samaritan Hospital, most of them recruited out of academic positions, who would never have come and be on our staff unless we had the research facility there and available. And it serves to stimulate the clinician to publish, to be up ahead of the game, and that's the advantage to the hospital. It adds to the reputation of the hospital, and I think the relationship between the NSI and Good Samaritan is practically unique in the country.
Perhaps you'd like to describe what problems you're working on at the moment. I know you haven't abandoned research. So, what problem of the cerebellum are you now working on?
Well, I have had the idea that the cerebellum modifies and perfects anything that has an input to it and an output to the area of the input. And Amaruzzi had that idea, and in our book we had a great deal to say about the relationship of the cerebellum to vegetative activity, and he had been very much interested in that. In the early 40s, I was asked to write a review for Biological Reviews, a British journal, on the cerebellum. And then in the search of the literature for that, I discovered for the first time that the dentate nucleus of man had two components, a neodentate and an older part, which was probably the same dentate that's present in the monkey and in the other animals. And what did that new part do? And we did some electrical stimulation of the association areas of the monkey and found that there was a certain predilection for those cortical things to go to the most lateral part of the hemisphere in the monkey. And so this is the part of the cerebellum that reaches such enormous size in man. And the cerebellum is very large in man compared to lower forms, and it is in association with the development of associations with areas of the cerebral cortex. I never had the courage to say, well, what does this do? Until I received a manuscript from a couple in Palo Alto, California. She, a retired mathematician who went to Columbia to study neuroanatomy for over a year or more. He was a computer expert working in the research laboratories of IBM. And he had read Sir John Eccles, St. Agatha, and Ito's book saying the cerebellum behaves like a living computer. So she sent, Henrietta Liner, sent me a manuscript in which they proposed the idea that there was a reciprocal relationship between the association areas and this the newest part of the cerebellum, and perhaps it had something to do with mental dexterity as opposed to motor dexterity, which was the idea prevalent throughout the whole of cerebellar physiology. This paper came to my attention when I was ready to go back to New York to present a paper to a symposium in honor of my old friend Boris Bender, who had been a fellow with me during my year at Yale, and we had been friends through the years. And we had a difficult time to get this paper published, but it eventually was published in a psychological journal. I think the title was something about, does the cerebellum have something to do with mental dexterity? And that's been my interest since. And meanwhile, we have been able to bring some very sophisticated psychological testing done, which tends to support this concept that yes, the cerebellum does have something to do with mental dexterity. And from the very beginning, and we realized that one of the techniques that could identify this with some certainty would be studying the metabolism of the cerebellum during mental processing. And if the cerebellum was activated during those processes, then it was being involved in some kind of mental function. And that's been my publications in the last few years.
In addition to founding a laboratory here and establishing a successful clinical practice, your interests expanded into epilepsy, and I wondered if you had any thoughts about the directions that epileptic research will take in the future, or how difficult it was to study epilepsy or to found a laboratory about it.
Well, I was interested in epilepsy as a clinical problem from the beginning because of my interest in electroencephalography. And it was only after electroencephalography developed that we really understood something about the mechanisms of the epileptic condition. So this was a natural subspecialty, if you will, of my clinical practice to be interested in epilepsy and the divisions of the different forms of epilepsy. It's a fascinating part of neurology to me. We were very much interested in making Good Samaritan Hospital a center of excellence in the treatment and diagnosis of epilepsy. And an opportunity arose to compete for a 5-year grant to establish an epilepsy center. And I went back to Washington and listened to the first presentation at the NIH about this, and decided, well, we'll make a stab at it. And we were successful in getting one of 11 feasibility studies to establish a center here. And I was project director for that feasibility study, and it was successful, and we had a lot of help from people like Bob Grimm and Bob Shook and Don Rushmer. And Jim Shimshock was project director for the 5-year grant, which was a liberal grant, $1 million a year for 5 years, and we were the only private hospital, the recipient of one of those. University of Minnesota was another, and the University of Georgia, and so on. This experience, of course, led to my further interest in epilepsy, and we were able to establish the Epilepsy Center of Oregon, and it's still in existence long after the grant has gone out of existence, and become self-supporting and an important part of the hospital's repertoire of patient care, including now the surgical attack upon those epileptic cases that do not respond to anticonvulsant drugs and can be helped by ablation of localized area of the frontal or temporal cortex, or even callosotomy has become a method of treating some otherwise intractable cases. I had an interest in Parkinson's disease as a clinician. I studied a few anti-Parkinson drugs in a very primitive way. Wouldn't be applicable today because they were just additive drugs in clinical trials, and was involved in the study of some 50 patients when L-DOPA and its derivatives became a useful tool in the treatment of Parkinson's disease. During that time, I became acquainted with Irving Spencer Cooper, who had perfected an operation to relieve some of the symptoms of Parkinsonism and became famous for that. And he, in turn, also was interested in cerebellar stimulation as a method of treating some intractable epileptic patients. And he and I became close friends, and we never collaborated in any scientific work, but I knew what he was doing, he knew what we had done. And these were my clinical interests primarily, though I was a general neurologist and was one of the founding members of the Neurological Clinic, which still is an active partnership at Good Samaritan, although I'm no longer a member and haven't been since 1985. I still see some of my epileptic patients that I've cared for many years. Most of them are well controlled. If they get too sick, I refer them to another epileptologist, and they admit them to the hospital. I don't admit patients to the hospital anymore.
The federal grant from the National Institutes of Health was then critical in establishing the Epilepsy Center here.
Absolutely.
But and I know another major grant was given to the institution from the Murdoch Charitable Trust, and there have been smaller grants from the Murdoch Charitable Trust. And I can recall that I was brought here primarily with a donation from the Millicent Foundation, which preceded the Murdoch Charitable Trust. I'm wondering whether you want to say a few words about the role of a local foundation such as the Murdoch Charitable Trust in promoting the expansion of research in Oregon?
Well, it's been vital. What happened was that after our experience with the 5 years of focusing on education, clinical care, and research in epilepsy, and the influence of epilepsy on social problems, and we had part of the research was done at the medical school and the Department of Pharmacology. It was all organized and farmed out, most of it. We felt that if we concentrated on different disease entities in the same way that we had on epilepsy, we could establish preeminence in various fields. And after 2 years of study and a lot of thought, we decided this was the way that we would go, and we would establish a neurological science center in which all of the elements of the hospital, the departments and divisions that had to do with the brain or the nervous system would be a component of the center, and that the Laboratory of Neurophysiology, which meanwhile had been renamed to the Neurological Sciences Institute, would be the research arm of that center. And we went to the Murdoch Trust and asked them for financing to establish the Neurological Science Center at Good Samaritan Hospital. And they were generous, and they gave us $850,000 over 3 years, over 2 years, matched by equal sum from the hospital, and the Neurological Science Center was established. They've been generous in supporting individual laboratories since, and as you say, the Millicent Foundation helped you get started. And so this has been a very important source of local funding, which is absolutely essential if we're to succeed and grow, because the federal government is an important source of funding, but it's only one source and can be quite time-consuming in preparing the grant applications. And one who's had experience in applying, you never know until the day whether you're going to be working in the future. And this is an insecure way of financing research. We need endowment, and this is what we're working toward as the future of this hospital.
This is an Oregon-type question here, but I'm wondering if you can characterize the response of people that you've invited from the East Coast to come visit you here. How have their expectations been different from what they've found here?
Well, I don't know. You mean other people that we've recruited to come into the laboratory?
No, visitors that come by.
Well, actually, Oregon is the most beautiful part of the United States, and I've traveled in many foreign countries, and I can tell you that this is an area that is delightful to live in. And most of them, I've been able to show them some of the beauties of the state and enjoy doing it.
How do you think eminent visitors have found the quality of the science here?
They've been astounded at the quality of the science and its national and international reputation, and the fact that it is a part of a private hospital. As I've said before, I think that is unique. And I look upon this as the same as you do a private university. There are certain things about private universities, as Linfield is a private university or a college. Stanford is a private university. These have certain advantages over public institutions, and I think they should be exploited. And this is what I am devoting myself now to, try to see that this can grow and develop in the future.
Okay, now it's an off the beaten track kind of question. Of all the people with whom you've collaborated, who was the smartest?
Who was the smartest? Maruzzi.
And why? And what's the evidence that you would give for that?
Well, he had linguistic skills. He had a knowledge of the literature, which was outstanding, that I never could have reached. He was an original thinker. No, I would say of all the people I've been associated with, he stands above anybody else. And I must say that what reputation I have is due to collaborators. I think Don Rushmore used to say, you con them into coming and then let them alone. And I've been very fortunate in the quality of people who have come, and then that grows and they attract other people. And I haven't had a great deal to do with the day-to-day, I haven't had anything to do with the day-to-day function of the Institute for many years, but when it was the Laboratory of Neurophysiology, I got the first grant and was able to attract funds from Millicent and other foundations locally, some of my own patients, and this has been gratifying growth to see.
We've changed the venue of our interview to the basement of the R.S. Dow Neurological Sciences Institute. The basement has recently been remodeled to accommodate 5 new laboratories. These laboratories include molecular biology, biochemistry, biophysics. I'm wondering if you envisioned that the Institute would expand to such a large group when you first started it 25 years ago.
No, I certainly did not, and it's been it has grown because of the quality of the people that we've been able to recruit to come to work at the Institute, and they are the ones that are responsible for its growth.
As one administrator to another, how big do you think the Institute can get and still retain the informal atmosphere that we tried to provide? What advice would you have for how to organize the Institute that might be different from the way you first envisioned?
Well, I don't have or would not have any preconceived plans of how it could be organized. I think the freedom that the hospital and the Institute provides, as long as a scientist is able to do what he wants to do, is the biggest factor in its growth and success. And I would want to emphasize that that be the way to see growth occur. Directed research by a director of research, I don't think is the way things grow. And I like the entrepreneurial aspect of this institute.
In building the Institute, how has the administration of the hospital facilitated your efforts?
I think it's the fact that the administration and the Board of Trustees has been able to envision the importance of a research institute of this caliber. The late Chester Stocks was an administrator during the early growth of this hospital research effort. And I owe a great deal to Chester because he would support me and could see the vision of the future in a way that I really appreciated.
Now that you have more time, since you've retired from the practice of neurology, how are you spending that time?
Well, I'm spending it at the hospital as a consultant to several divisions and departments. I am a consultant to the Educational and Family Support Department headed by Bobby Haggerty, and I'm very much involved in her activities as an advisor and consultant. I still read electroencephalograms one day a week, and we have a fellow here now from China who is reading the records, and I look over his shoulder and advise him about that. I have my office actually in the same floor as the Good Samaritan Foundation. So a good share of my time is devoted to fund development for the hospital and for the institute and for the center. And I enjoy that work. I like to interest people in what the brain is about, and enough so they know that if they give money for research on the brain, it will pay off in the long run.
I know some of your travel has taken you to Guinea and related to cerebellar disease and the caused by the Kuru, the slow virus.
Oh yes, that's an interesting subject. Sir John Eccles was responsible for that opportunity, and he introduced me by letter to Dick Hornibrook, who was at that time, this was back in 1965, was studying Kuru in the remote part of the highlands of New Guinea. And we were invited to go there and visit, and I examined 9 patients with Kuru, and in the early stages of their disease, it is a pure cerebellar disorder. As the disease progresses, the patients become demented, but as it develops, the cerebellum is a major part of that disorder. And of all the places we have traveled, I think the highlands of New Guinea in 1965 was a very primitive area and a very enjoyable visit, and I owe a great deal to Dick Hornibrook for letting us come and be with him for a few days.
Subsequent to your visit there, and due to the persistent efforts of Carlton Gadjacek, he won the Nobel Prize, didn't he? Based on the
he had
for the Kuru virus.
He had been able to show that Kuru was a slow virus disease, and demonstrated that it could be reproduced in the chimpanzee at the National Institutes of Health. But at the time I was there, the cause was unknown, and his work had not been completed. You asked me what the greatest disappointment was in my scientific career, and that was the fact that the cerebellar stimulation has not become an accepted mode of treatment for patients with intractable epilepsy who are not either suitable candidates for ablative neurosurgery or who have failed after operations have been done. The prejudice against cerebellar stimulation has been present for at least 20 years after it was first attempted by my friend Irving Cooper. And this, I can't really understand how this has been, but it exists. We attempted to include a controlled study on the application where we established the Comprehensive Epilepsy Program for Oregon, and it was deleted from the application. This was a disappointment. And we're now attempting to bring some further information about this through patients in our surgical program for epilepsy, among those who are not considered good candidates for either callosotomy or temporal lobectomy, or who have failed those operations. Very recently, we admitted a patient who Cooper had put a stimulator in 1974 to the hospital for monitoring between the time that the antiquated stimulator was removed and the new stimulator was put in place. And we had her in the hospital for a week between those events. Random computerized samples of the EEG activity while the stimulator was off and while the stimulator was on again. And we found that the paroxysmal discharges occurred in an equal time of 75 minutes, was 44 when the stimulator was on and 119 when the stimulator was off. This we presented at a poster for the last meeting of the American Epilepsy Society. The question you asked, that what was the most enjoyable period of my scientific career, it would have to be the banquet, which was a part of a symposium on epilepsy on my 80th birthday year, held here, and colleagues from around the country arrived to participate in that symposium.
Another person that has come to honor you, Dr. Dow, from across the Atlantic, Dr. Mani, who is Dean of the Catholic University in Rome, Italy. Dr. Mani, would you say a word or two?
I am very happy and pleased to be here again, because I have been one of the first investigators in the lab founded by Dr. Dow at the beginning of the 60s. However, in my heart, Oregon, and particularly Dr. Dow's, was still present, and I am very happy to be here and to have the opportunity to express all my gratitude to Dr. Dow, because I have learned very much from him, and the stay in Oregon in his lab was fundamental for my career.
I'd like now to introduce Dr. Perper, who is Dean of Albert Einstein Medical School in New York, and has come here as the 8th Neurosciences lecturer. Dr. Perper?
I suppose my only Portland connection is I love salmon, and so I'm in the right place. I just want to spend a few moments saying a few things. One, a congratulations to Dr. Dow and Mrs. Dow, whom I met for the first time and asked her how long they'd been married in their 54th year. And I think that just deserves all kinds of wonderful things anyway. But in thinking about that, I thought of all the friends here of Dr. and Mrs. Dow, friends that have represented to them not only connected, grateful patients, whom there must be legion, the number of patients that Dr. Dow has seen, but friends with a spirit and enthusiasm for the same kind of mission that he has seen, which is to build a strong neurological sciences program within the clinical domain, and the importance of that. And what I see is the kind of interaction here between the basic sciences of neurology and the clinical sciences, and that kind of transfer of information, which is such a healthy catalytic kind of action. And I think it would be wonderful if we could replicate these centers in a lot of other places, and perhaps we ought to. But to do so will require that kind of bonding mechanism that exists with the laity, who look to a relationship which is not simply one that first begins with gratefulness and then extends itself into pure optimistic philanthropic support for its own sake. That's really the final transition, and I see such a success here. I think I'm talking too much. I'll sit down now.
Dr. Dow, I mentioned to you earlier that it really is quite a tribute, I think, that there are so many people in this room that have come tonight to honor you. But there are also a number of people who would like to have been here that aren't here and who've written in order to express their regrets of not being able to be here. And I'd like to read some excerpts of some of these letters and to let people know just who really considers this man the very special man that he is. From the Comprehensive Epilepsy Program of Minnesota, Mark Yerby. I've lost my place for a moment. I have such fond memories of my years in Portland and the excellent training I have received from Dr. Dow and his colleagues, and he regrets not being able to attend. Yarabayashi, also from Tokyo. I wish to congratulate Dr. Dow and admire his great achievements and contribution for many years in the history of neurology.
Mrs. Dow, it is because of you that Bob Dow, or Robert Dow, Dr. Dow, and that word goes hard over my lips, the word Robert, and I've told you that, I just can't say it either, is because of you, you've made Dr. Dow what he is, no matter how difficult a task that has been. So in appreciation from all of us, I would like to give you a framed picture of Dr. Dow on the brochure that was used for the conference this year, and the bouquet of roses, and to say thank you very, very much. I appreciate it.
Therefore, in grateful recognition of your many years of distinguished medical leadership and outstanding community service, and in honor of your pioneering establishment of the internationally recognized Research Institute at the hospital, the Board of Trustees of Good Samaritan Hospital and Medical Center does hereby announce that the Institute will henceforth be officially known as the Robert S. Dow Neurological Sciences Institute. And in recognition of your many philanthropic achievements, the hospital trustees also announce the establishment of the Robert S. Dow Fund for the establishment of research and education in the neurosciences. This citation is signed by the Bishop, the Chief Executive Officer of the hospital, the President of the Hospital Board, and the Chairman of the now Robert Dow Neurological Sciences Center. Congratulations, Dr.
I've often said that my role here has been to con people into coming and then let them alone. And I think that's a good principle of leadership, provided you find the right people. And I know that I have been fortunate to find the right people. And I can't begin to name those who are responsible for the success of this program that has developed here. It's not my doing. It's those who came and who were allowed to be entrepreneurs in science. With that, I think I've said enough. I know you know how I feel, how grateful I am, and how wonderful it has been for all of you to come. Thank you very much. You also asked me about what Willetta, my wife, and I do now that I'm retired. And one of those activities are fishing. We have fished on the Rogue River many times, and once down the Middle Fork of the Salmon. The trips that we have taken, we have included one with our daughters to the North Cape and the west coast of Norway before they were married. We have taken trips to Kuru, we have taken trips to the highlands of New Guinea to observe patients with Kuru in 1965, and this was probably the most interesting of any of our trips. A trip to China, mainland China, with other neurologists and neurosurgeons in 1981 was a memorable trip. We have also traveled to Kenya and Egypt in 1982. We took a trip to Alaska in 1984. One of our most memorable trips was with our two daughters and their husbands and our grandchildren to Europe in 1987, including a dinner at a restaurant in Florence where we had eaten many times when we lived in Florence when our girls were 8 and 10. We've also taken trips to the Antarctica in 1988, to Indonesia and Bali in 1989, and these trips are part of our recreational life. Of course, we do have a second home at Black Butte Ranch, where we go on long weekends during both the winter and summer.
How big do you think the Institute can grow and still retain the rather informal atmosphere that we have been successful in maintaining?
Well, that's a difficult problem. I think it will depend upon the fund development that we are initiating at this moment. If we are successful in obtaining the kind of support that will see to it that there is an easy transfer of scientific information to clinical utilization, and that can be done in a private hospital without departmental barriers to a degree that is not possible in many bigger institutions. And I think the staff will decide what areas of research that they need to get into. We know that we don't cover the full range of neuroscience. One of our priorities was recently to be able to bring molecular biologists here. And we were able to raise funds through the Cooper Foundation, through the Murdoch Trust, and through other private sources to bring in these scientists which don't approach the nervous system with electrodes, and we get more fundamentally into how the nervous system works. I think what we need for stability of this growth is endowment, as I've mentioned before. And we are hopeful that we can attract the kind of funding that will permit this institute to have an endowment of substance.
Well, this concludes our interview. I must say I've really enjoyed it. And even though the last few questions have dealt with your retirement. I don't think there's a member of the Institute or of the hospital administration that really believes that you have retired. In any event, I want to thank you for participating in the interview.